Hello guys, welcome to my YouTube channel. Today we are here to solve Leetcode problem of the day, and the day is 8 September 2024, and the problem is split linked list in parts. Let's try to read the problem statement first. Given the head of singly linked list and an integer k, we'll see in the example. Head are given and an integer k is given. Okay, split the linked list into k consecutive linked list part. The length of each part should be as equal as possible. No two parts should have size differing by one. It means that if there's the two part, any two part must have the size difference equal to 1. It means that either of them can have at most one size greater than the previous one. This may lead some part being null. Yeah, you can see here that these are total 10. Sorry, it's not these are see the example number 1. Here you will see this head is given and k is given because the k is only 3. So 1 2 3 and these two part are null. So that's why it's saying that this may lead to some exception being null, and the parts should be in order of occurrence in the input list. Yeah, this saying that you can't sort them, or you can't change the order of the input list, and the part occurring earlier should have a greater size greater than or equal to the part occurring later. As you can see here in the example, each part should have almost equal size, or maybe it's greater one only, should be one more size. So here is 4 and here is 3 and here is 3, and because there was one more node, 3 3 3, one is left, so we will put that remaining in the previous list. So this is all about the problem written, and what the output expectation is written on array of the k parts. So let's try to visualize how we will approach the problem and how will we will come with a solution. Okay, these are the nodes that are given in this example. The example number 2, these are given, and k is asking for 3, and these are the examples. So total of 10. So because it was asked, the problem is asking that each part should have equal size, so we will first find the total size, and the total size is, as you can see here, is size is 10. So if you divide by 3, then approximately 3 member should be there in each group. So if you will divide by 3, then there are the three part 1 and part 2 and part 3. These are the parts. So each member we will first these 3 and 3 3, and one member is left. So how you will find the number? We will just do size equal to 10 divisible by 3. It will give you 3, and we will make another variable, remainder will be equal to 10 modulus 3 equal to 1. So these remainder we will put these remainder at the beginning of the list. So let's suppose that you have only one remainder, so these are the three. These will, so these size should be 3 and 3, and we, in this one remainder we will put here at the beginning, so it will be 4 and then 3 and then 3. And this is the approach that how you will put members in each in each list. So these are the approach that how we will distribute. So these are the, this will be the distribution. These 4 member will be in one group, and these 3 members will be in one group, and the remaining will be in the one group. And you can see that here the size is 4 and 3 and 3. If you will pick up any of the group, the size difference will be always, size difference will be always less than or equal to 1. You can pick any of them, less 4 and 3 in this, and this is the way that we will distribute. And you can also, if you are familiar with linked list, you can find the size very easily while you will iterate. While, let's suppose a variable is here, let's suppose temp, then you will just iterate temp. While temp is not null, you will just store the total size. So this is the way we will find the total size. Okay, and what you just have to need, you just have to broke this link, and this, the address of this node will be put, we will put here, and the address of this node we will put here, and the address of this node we will put here, and here we will, in the next of this node we will put null, similarly here as well, and that's it. And this is all about the problem. You just have to make the size, first you have to make the size of each, and then you will iterate. Let's suppose you need to have the size 4, then you will just iterate 4 times, and then put next to the, to this node null, and we will start again, and we will just put this, the address of this node to the next list. And this is how we will approach the problem. And there, let's suppose one more example is there, just like here. Let's suppose similar example, 1 2 3 4 5 6 7 8 9 10 and 11. In this case the size is 11, and total size is 11. Let's suppose total size, and the size of each group will be equal to 11 divided by, sorry, divisible by 3, so it will be equal to 3, again 3, and remainder will be this time 2. So what we will do, we will just, and then each group should be of size. So at the beginning what we will do, we will iterate 3 times. First we will count the total size of the current list, it should be. So what we will do, we will just iterate 3 times here. 3, the total count is 3, and if the remainder is not 0, each time we will reduce the remainder and include a single member in the current group. So just like you have 2 remainder and 3 members will be there, so total 1 I will include to here. So this, it will be total of 3 plus 1, and remainder will be minus minus. So how much will be the remainder? Remainder will be equal to now to 1. So 4 member you have to include in the first group. So how we will perform? Go to here till here, and total will be 4. So I will exclude from here, and include this member in the first list, and again we will I will find the size of this next group. So how you will perform 3. If the remainder is greater than 0, we will include one more. Okay, then total will be 4, and the remainder will be now 0. So 4 member you have to include now, 1, 2, 3, 4, and these member will be in the second group, in this group. And because the remainder is 0, so 3 plus 0 will be equal to the size of 3. So 3 members will be in the next group. So these 3 member will be in this group, and these 4 member will be in this group, and these 4 member will be in this group. And this is the approach how you will solve this problem. It's is the problem of the linked list. You just have to broke the link and store the address of the next node in the next list, and this is how you will solve the problem. Let's try to code it now. Okay, first to store the answer, of size should be equal to k. Okay, then I will make a temporary variable, suppose temp equal to head. Okay, now temp is not equal to none. Actually I'm trying to in this while loop I am trying to total size of the given linked list. So while temp is not equal to null, what will I do? Total size plus plus, and this is the way you are able to you are this is the way sorry this is the way you are able to find the total size of the given linked list. So int size, and this is the size that each group should have. So size will be equal to total size divisible by k, and what will be the remainder will be equal to total size modulus k. So this is all about, and then now again we will assume temp equal to head. We will start from the beginning now. While temp is not sorry so till here what we have done yet, we have calculated the total size of the given head, and here we have calculated that at least the each group should have the size equal to the size variable, and these are the remainder that will be left after distributing members equal to the size in each group. So and these are now I am iterating. So we also need a variable here previous, because you have to assign null. You can say now if you will reach here our temp variable, when the count will be 4, it will reach here till it will reach here, but the previous our previous pointer will point to here, so that we can put in the next of this node null, so that this link could be broken. So we will just the temp here, and we will have to first calculate the total size of the current list. What should be the total size of the current list we are preparing from the original linked list? So let's suppose here we say count will be equal to the size. Okay, if remainder will be greater than 0, suppose remainder minus greater than 0, we will increase the count. And this count variable says that the current group should have at least the member equal to count. So now while count minus minus is greater than 0, what we will do, we will, so now you have to answer of I, you have to make a extra variable index for indexing, int I equal to 0, I plus plus, we will assign it the temp node. This is the temp. Actually in this line I am assigning, actually I am assigning the address of this node, address of this node, address of this node, to split in the different linked list. So here we came, and now we have done, we have assigned the address of head variable of head node of each group, and now we will assign previous to the, sorry, now we have to assign previous the temp, and you have to move temp. So this is the way temp will move to the next node, and the previous will store the address of previous store, so that we can update, like we can update the next of this node null. So previous will point to when the temp variable will reach here, previous will be here, so that we can put null to the next of this node. Similarly to the next, whenever the node temp variable will point to this node, we will, previous will be the here, and we will put the next to this node null. So this is the way we will solve here. Count is greater, then we will just do here. Let's try to run it first. So why is the wrong answer? Let's see. 1 2 3 and 2 3. Okay, your output is 1 2. So this is the is that, oh sorry, we have, why is that? Because we have forget to assign null in the next. This we have forget. Let's try to run it again. So these are the two output, and it giving us the correct answer. Let's try to submit it now. Our code has been accepted now, and it's beating 100% of the people who have submitted in Java. Memory it has taken 4343 MB. So this is all about the problem, and let's talk about the time complexity, because here in this we are just iterating once, and again in below we are iterating once. So the time complexity is, so time complexity will be order of 2n. where n is the total size of given linked list. So this is all about the problem. If you feel it is helpful for you, you can suggest to your friends, as well as you can subscribe my channel. You can comment me below if you are any suggestion or any query related to this problem. Make sure to like my videos. Stay healthy. Thank you. Good luck for the day.